your fact tables will typically have some kind of dates in them that might be transaction dates or posting dates and so on. And normally you won't find time associated with that, although sometimes you may. If you do have time, you need to be extra careful. But in the base case, our dates will typically not have specific time associated, or all the times are the same like these. So I have two tables here. I have a sales table, and it has a date key, and that's the date that we're summarizing sales to. And then I have a sales quota table that also has a date key. And it's possible that I could just use these date keys when analyzing the data. So I would first have a pivot table that had the sales by date, and then another pivot table that had quota by the quota's date, but those wouldn't be really connected together. So what we almost always do when we're doing date analysis is to have a specific date table. We need to talk about the specific requirements for that date table, because many of the calculations and relationships and visualizations that you'll do have some assumptions about what your date table looks like and how it relates within your model. So first of all, that date table needs to have a date or a date time data type as the primary key. In data warehousing, the best practice over time has been to use integer keys for date tables, and we can still use them technically, but we also have to have an additional column that stores that date key as an actual date, because when DAX does its date calculation logic, it's going to be looking at actual date columns rather than integers. So we just need to make sure we have that in there. If your data warehouse currently uses integer keys for your dates, simply convert those in a calculated column to a date data type, and you'll be good to go. The next is we really should have contiguous dates in the date dimension with no gaps. Sometimes we might have made a date dimension that only included the dates that exist in our data model and have not included dates where no data exists. This can be a problem when we're designing calculations. For example, if we do a year-over-year calculation and the prior year is missing the rows for the date that match, that calculation will return invalid data. So just make sure that all the dates are represented in the date dimension if we're using one that goes to the day level. Additional level columns are optional but are recommended, and when I say level columns I mean things like year and month and quarter, business day, etc. Technically a date dimension could have one column that only had the date, but usually we'll have some of these descriptive level columns that make analysis a lot easier. In SQL Server Data Tools you can mark one of your date tables as the date table, and that has some special meaning within calculation. Choose the one that's most commonly used to mark that as the date table. And why would you have more than one date table? And the reason is because role-playing dimensions are not supported in tabular mode. So in multidimensional mode we can have one date table and then relate it to 4 or 5 columns in a fact table if we want to. We call that a role-playing dimension. In tabular mode, role-playing dimensions aren't supported. So if we have those 4 or 5 columns, like in an order table we might have order date, ship date, etc. If we want to keep those columns in that fact table, we would need to create multiple copies of the date table. We just import it into the table with 2 different queries. We can still maintain one table underneath. The other option for simulating role-playing dates is to use a feature called inactive and active relationship. We can activate the relationship between one of the columns in the fact table and the date table for one calculation and then have a different relationship for a different one. This really only applies to calculations, and users don't have the ability really to activate relationships. So think of this in terms of calculations only. So if you follow those recommendations, then you'll end up with a date table that looks like this one. We have a single column that is the primary key, and that's a data type. It's okay if we had an integer key for the date next to that, as long as we did create this column to use within the tabular data model. And then we do have a lot of level columns over here, like which week of the year it is and what the day of the week is and so on. And these just make analysis much easier. And we've related that date table to a couple of fact tables. And these fact tables have measures. The sales has a sales measure. The sales quota has a sales quota measure. And the way that I can use that then with the single date table in Excel, for example, is I can choose the sales and sales quota, and then if I find my date dimension and choose, say, the calendar year, I can slice both of those measures by year together on the same row, and that's made possible because I've related the same date table to both measure groups or both fact tables.